A few things to know when we are working with determinants. For easier calculation, we shall expand the determinant along the row or column which contains maximum number of zeros. Okay, what does that mean? If I have a matrix, I can use any row or any column to expand it to get the answer. That you guys know. And all the answers are equal. Now, what we are trying to tell over here is make use of the row or the column which has a maximum number of 0, which is easy to calculate. For example, in this case, pick row 2. With 2 zeros, this is the best option to go with. Now, in this case, we have to pick which one? Well, row 1 looks promising, row 2 also, row 3 also. But if we go to column, this is the best option to go with. Pick column 3. Okay guys, that's the first note. Second thing has to do with while expanding, instead of multiplying -1 to the power of I plus j, we can multiply by 1 or -1 according to I plus j being even or odd. So this is your sign map. So basically what they're trying to tell is this. Using such a map in your mind, you can end up with 1 minus 1 1 minus 1 1 minus 1 1 minus 1 1. So this is what we'll end up with, this because this will be even odd even odd even odd, so on and so forth. So in this case, in the previous case, you'll end up with this is odd even and odd, while over here this is minus plus plus minus plus, and this is negative and this is positive. So this is how you can remember. So you can make use of something called a sign map. So we can make use of that, and this will help us calculate things faster. So here basically if we expand with first row, it will be minus plus minus plus. Second, it will be minus plus minus and plus minus plus. Depending on the row and column, you guys can pick the signs accordingly. And finally, we have, if we have a matrix, say A, which is k times of B. In this case, A is 2 times of B. Look at each element, map it, right? Clearly, sorry, it's the other way around. Oh, no, this is what it is. B into 2 times will give us A. Correct? Is this correct? B into 2 will give us A, and A divided by 2 will give us B. If it's so, then the magnitude, not the magnitude, determinant of A is equal to k to the power of n, whatever the constant may be, to the power of n, into the magnitude of B, where n is the order of the matrix. Okay, so here the order is 3 by 3. This holds good for all the matrices. It's just that we have to be careful with n. Okay, so if B happens to be, say, minus 14, again if, right, and if A happens to be say 3 times of B, okay, and we have B to be of order 3 by 3, so obviously A will also be of order 3 by 3. So this is one example actually, so let me not combine with that, you guys will get confused. Now magnitude of A will be 3 to the power of 3 times of, not magnitude, sorry, determinant, and so this is 27 times of minus 14. Okay, yes, yeah, that is that, and yeah, in this case a will be 3 square times of determinant of b. I can use some other variables over here so that there's no confusion. So this is c, and c, c, c. Yes, I would like you guys to write all of this. Sorry, this is 2 cube. 2 cube. 2 being the factor and 3 being the order.